Lesson 10 in Theory of Road Vehicle Motion. This is the first lesson in the second section of the course, which will cover vehicle statics. In this lesson, we will cover the basics of trigonometry that we are going to need when decomposing forces. Don't let the scary word trigonometry fool you. This is very simple, as you will see in this quick little lesson. First off, what is trigonometry? The word trigonometry comes from two Greek words. I'm sorry in advance to all Greek-speaking people. I don't speak Greek, so I may be going to butcher this. The first word, trigonon, which means triangle, and the other word, metron, which means to measure. In the last lesson, I showed you a metronome, which is also a measuring device. Let's just quickly go through all of the types of triangles we have. So we know that trigonometry is measuring triangles. According to its sides, we can divide types of triangles into three groups. The equilateral triangle, which has all of its sides equal. The isosceles triangle, which has two of its sides equal to each other. And the scalene triangle, which has all of its sides different. So every side has a different length. According to its angles, we can have an acute triangle, which has all three angles acute. An acute angle means that it is an angle smaller than 90 degrees. We can have an obtuse triangle, which has one angle that is larger than 90 degrees. And we have the right triangle, on which we will focus when talking about trigonometry. So, focus on the right triangle. And a right triangle is a triangle which has an angle of 90 degrees. So it has one internal angle that has a value of 90 degrees. Remember, the sum of all interior angles of a triangle is always 190 degrees. That's why a triangle can't have two 90 degrees angles, because it would, have the sum of 180 degrees and it wouldn't be a triangle. Measuring triangles. Why do we need this? Why do we need trigonometry? Well, trigonometry can help us find unknown angles and distances. This right here is a right triangle. First, let's learn the terminology. The longest side of the right triangle is called a hypotenuse. And then, depending on which angle we've chosen, we have the opposite side and the adjacent side. So from the point of this angle alpha, this is the opposite and this is the adjacent side. If we chose, for example, this angle right here, and let's call it beta, for example, in this case, if we use this angle, this is going to be the opposite and this is going to be the adjacent side. Now, let's say we have two distances, A and B. We have to find the length of the hypotenuse and we need to find the angle alpha. Now, trigonometry helps us do this. It also helps us find the adjacent side, the opposite side, etc. You'll see how it works. The three main functions of trigonometry are the sine function, the cosine function, and the tangent function. You're mostly going to see their abbreviations: SIN, COS, and TAN. Now, what do they do? These functions and angles give us the ratios of sides of the right triangle. For example, the sine alpha function, in this case, will give us the ratio of the opposite side and the hypotenuse. If you are wondering what this stands for, is this a magic spell or something? It is just a fun little phrase to help you memorize the equations for these functions. So it says so, ka, toa. So being sine function is equal to opposite divided by hypotenuse, so SOH, okay, and then we have ka, we have cosine adjacent hypotenuse, and we have toa, we have tangent opposite adjacent. So remember this little magic spell, SOHCAHTOA. Let's do a simple example so you can see how it works. Okay, so here we have a triangle, and we know its hypotenuse. And we know this angle right here, it's 45 degrees. And we know that the hypotenuse is 20. We won't focus too much on units right now, so it's just going to be 20 something. It doesn't matter for now. Here we have a table that tells us the values of some generic angles. You can see that the sine of 0 degrees is 0, the sine for 30 degrees is 1 divided by 2, or 0.5, the sine for 45 degrees, so on. We are going to use this table in this little example. Okay, so for example, we want to know the length of this opposite side, the green one. So we have this angle, this is the opposite side for this angle, and we know the hypotenuse. So we write the sine of 45 degrees is going to be equal to the opposite side, right? Opposite side divided by the hypotenuse. So sine 45 degrees is equal to the opposite side is, we don't know it, so we're just going to write opposite divided by 20. So if we multiply this entire equation by 20, we get 20 times the sine of 45 degrees is equal the opposite side. So 20 times sinus 45 degrees, okay? For sinus 45 degrees, we look at this table and we see that it is equal to 1 divided by the square root of 2. So it's 20 times 1 divided by the square root of 2 is equal to the opposite side. So it's basically 20 divided by the square root of 2 is equal to the opposite side, and this is equal, if we put it in the calculator, you can do it yourself as well. So 20 divided the square root of 2 is equal to 14.14. Okay, so 14.14. So we found that this one is equal to 14.14. Let me erase all the ink. So now we know that this is 14.14. Okay, let's try to find the adjacent one. So the function we use for the adjacent side is the cosine. So we have cosine of 45 degrees is equal to the adjacent side, okay, adjacent side divided by the hypotenuse 20. Okay, again, let's multiply by 20. So we get 20 times the cosine of 45 degrees is equal to the adjacent side. So cosine of 45 degrees, we go to the table and we see, okay, so cosine of 45 degrees is the same as the sine of 45 degrees. It's 1 divided by the square root of 2. So you get 20 times 1 divided by square root of 2 is equal to the adjacent side. Now, we already did this. This is 14.14. This is the adjacent side. Now, you see, they are the same. Why? Well, we started with the angle of 45 degrees right here. If you look at a square, you know that if you pull a diagonal between these 2 points, so this is a square, it has all of its sides equal, okay? So if you pull a diagonal, it's going to be an angle of 45 degrees. And of course, if this is a right angle, which it is, this is also going to be an angle of 45 degrees. So this is basically a square that is sliced. We saw that from the trigonometry functions, and we saw that when we calculated both the sides being equal. So we saw how we use this in practice. Now you probably saw how the sine and cosine functions look like when you plot them on the x and y axis. These are these beautiful wavy functions. Here we have the sine function. So the y-axis value which ultimately is the ratio between the opposite side of the angle and the hypotenuse, okay? And you can see how first it rises, and then it goes down, and then again it rises, and it repeats itself like this. So the part which we take as the repeating part is one period. So after this period, we get another same period and another same, and so on, so on. So this one period, it starts from 0. So it kind of, you see how it goes to 1, and then it goes to -1, and then again it goes to 1, and so on, so on. The difference between the sine function and the cosine function is that the cosine function starts on 1 and the sine function starts on 0. So you can see that the period is the same. It is 2 pi, but the difference is where the period starts. It is shifted, okay? So we have 1 and then it goes to 0, it goes to -1, and then it goes to 1 again. So this is the period. Now this period of 2 pi is in radians, and if we convert 2 pi radians into degrees, we get an angle of 360 degrees. So this is one full rotation of a circle. Let's look at a fun little animation I found on mathisfun.com, which will help you understand this even better. I found this great little animation that can be used to make this even more clearer. The link between this wave function and the right triangle sides and the angles. There's a link in the resource part of this lesson for this website. The website has a lot of information on trigonometry functions and also has a lot of animations and illustrations that will help you understand trigonometry. Now here we have a circle on the right side and we have the sine function on the left. You see how it starts? Now the hypotenuse is green, the adjacent angle is blue, and the opposite angle is red or pinkish. So you can see how the value of the pink side, the opposite side, changes with the sine function. Now this is the cosine function. It starts on 1. Okay, so you can see it starts on 1 and then goes down, and this is the period for the cosine function. I strongly recommend you check out the mathisfun.com website, specifically the link that I put in the resource part, and try to play with this circle and see all of the different illustrations and explanations for trigonometry. Now, the fun example we've all been waiting for. I'm going to show you how we are going to be using trigonometry functions, and we're going to do a little force decomposition, which ultimately we're going to do through this course, and we're going to do this when we start analyzing the forces that occur on road vehicles. So we have this force F that is acting on something, and between this force F and this x-axis, there's an angle of 30 degrees. When we write equations of equilibrium in our static systems, we divide the x-axis forces and the y-axis forces, okay? So we have to project this F force on both of these axes in order to write them in the equations for the equilibrium. So first, this F function is, as you can see, the hypotenuse for this triangle right here. Okay, so this is a triangle, a right triangle, and we know that this angle right here is an angle of 30 degrees. So if we want to plot this F force on the x-axis, we have to use what? The cosine function, because this side is the adjacent side. Okay, so this is the adjacent side. So first, let's write the equation for the cosine. So cosine 30 degrees is going to be equal to the adjacent side divided by the hypotenuse. Okay? In this case, the hypotenuse is known because the hypotenuse is the force F. Okay, so this is the force F, and the adjacent side is the force Fx. which is the x-axis projection for the force F. So if we multiply everything by F, we get that Fx is equal to F times cosine of 30 degrees. If we go back to our little table that we had for the functions, okay, you can see that the cosine of 30 degrees is equal to square root of 3 divided by 2. So Fx is equal to square root of 3 divided by 2 times F, okay? This is the projection Fx. Now, what about the vertical projection? Now, the vertical projection is the one right here. So this is Fy, okay? So Fy is unknown. We know the hypotenuse, and we know that Fy in this case is the opposite side for this right triangle. So we write the sine function. So we write sine of 30 degrees is equal to the opposite side divided by the hypotenuse, okay? And of course, sine 30 degrees is equal to the opposite side, which is Fy divided by force F. We multiply everything by F. What we get is F times sine of 30 degrees is equal to Fy. And if you go and look at the table, or you put sine of 30 degrees in your calculator, just make sure you're entering degrees and not radians, you get that the force Fy is equal to 1/2 of F, okay? So this is the Fy projection. Now for your homework, I want you to try projecting the forces from this angle right here, okay? So we know if this is an angle of 30 degrees, we know that this has to be an angle of 60 degrees, right? Because this whole angle is 90 degrees, 90 minus 30 is equal to 60. Because we know that this one is 60, now something has changed. Now this is the angle that we're using in our trigonometry functions, so this F stated the hypotenuse, but now this time the projection on the x-axis is going to be the opposite side, and the Fy is going to be the adjacent side. Use the table on slide 6 and see where the values for the ratios are actually the same. You're going to see sine of 30 and cosine of 60 going to be the same ratios. And this is it for the lesson on trigonometry. After this lesson, there will be a quiz regarding this little homework, so pay attention. Thank you for listening and for staying focused, and see you in the next lesson.